Neurips 2024, part 14, Buffer of Thoughts. This paper touches upon the inference and reasoning models that have been coming up recently, like O1 of OpenAI. I think it's a very interesting paper. Like most of these papers at Neurips, it provokes further thought, more deeper understanding of a particular problem. In this case, what we're talking about is reasoning. And I think if you summarize the situation of reasoning, it's the following: like, we have the training of foundation models, which is basically a compression of knowledge in vector form, so it can be retrieved, or in latent form, so it can be retrieved. And now we could have the same idea. Technically, we could have the same idea also on the inference side. That means we could have a collection of potential solutions to problems, and then we could query those solutions, and that's what we call reasoning or inference. So specifically what this paper does is it tries to find structure within problems and then assign certain problems to certain problem templates. So for example, if you have, if the problem that you're trying to solve is, let's say, you want to optimize, sales given a certain amount of costs, given a certain amount of labor exposure, things along those lines, then that is the structure of this problem is a quadratic programming problem. So you could then assign this problem to the quadratic programming template, and then solve within the quadratic problem template, which in itself has been already evolved into solutions. So what you don't have to do in this context is you don't have to sort of start from scratch and do a one-shot or multiple query type prompt evolution in order to find a solution to the problem. You can read the problem setting, assign it to what they call a problem buffer, and then within the problem buffer find the right structure of solution to attack the particular problem. So this is one solution. There could be another type of problem, which is a sorting problem. So you want to know, let's say, what's the best restaurant in Lisbon given your budget. So for that, you have to first define what best is, and then you have to sort best according to to your list. So this is a sorting problem. So like we have different types of problem sets, and we have different types of solutions. So I think this is really what's so exciting about this this paper. And I want to talk a little bit about sort of general attitudes towards this reasoning type situation set, right? So think about it this way: like, imagine you have a large language model. What has been the breakthrough of foundation models or large language models? Let's call them foundation models just for nomenclature. Like, what has been the breakthrough here? The breakthrough has been that we've been able to train massive amounts of data read online, and then compress it in latent space, so we can then query that that particular database, and have general solutions to problems. This is roughly what foundation models offer. And with more evolution of these foundation models, we've found different types of use cases, and one of them being it can answer questions. The other is it can sort of act like an operating system, and so forth. Now we can imagine a similar type attitude towards inference, right? You could have lots of not every problem has its own unique structure. Most problems, like I said before, let's say an optimization problem is a quadratic programming problem. So there's a lot of optimization problems in the world. There's a lot of sorting problems in the world. There's a lot of programming problems where you have to, let's say, use a certain programming language to define a certain engineering task. So there's a lot of these types of structured problems. They can be templatized into what this paper calls a problem buffer, and then searched. So when we have a problem formulation, we can then search and find that, okay, this particular task fits into this type of problem buffer. So let's use this to find the solution. So if you think about it, and the paper talks about other attempts. For example, tree of thought. Tree of thought is sort of an evolution of chain of thought. Chain of thought is, I would say, sort of the first, somewhat revolutionary discovery that with a specific type of prompting sequence, you can get more out of a model, assuming the weights are fixed, right? So you have fixed weights, and you can still get more out of a model. That is chain of thought. Tree of thought is sort of the same idea, but now you have sort of a tree of solutions, and then you pick the right one. So what we're seeing here is kind of an evolution towards, an iterative approach in finding optimal solutions to problems. And we could combine this iterative approach with a structured approach. So we could have certain structures that, again, like if I have a certain task which is clearly a quadratic programming task, well, then let me just use that quadratic programming task, and let's use the template which is already predefined and has given me good results and so forth. So I can then just use that. So I don't have to, when I do the actual inference, I'm not starting from zero. I'm not starting from scratch. I already have a head start because I pre-structured the problem set already. So this is the idea. And I think, like I said, what I find most exciting in this context is really sort of the iterative approach from try and error, like in a tree of thought type of way, towards a structured way, and then sort of find a balance and have a, if you will, a foundation model for solution, a solution foundation model. So the same way we compress knowledge in foundation models, we could also compress solutions in a foundation model type setting, and then access those solutions whenever the problem is set. Now, what are the issues with this? Of course, first and foremost, we have to be very clear in tasks. So this is good for tasks that repeat themselves. For example, if you're Capital One and you're building a foundation model for an interactive agent that picks up the phone, basically an artificial agent that deals with customer queries. Like if you're Capital One, you're gonna want to deal. You're gonna deal with a lot of structured problems. You're gonna have credit card denials, credit card losses, limit liftings or limit reductions, things along those lines. So the problem set is pretty is known, and in this type of context, I think it is actually fairly. This would be a very good application for this type of buffer of thought, which is that because we have a preset type of problem situation, we can also structure the problems and quickly identify whenever, let's say, the person is on the phone and says what she needs, you can already identify the structure of the problem and then attach it to the problem buffer and solve the problem. Versus, of course, if you're dealing with more sort of ephemeral one-shot type problems where creativity is necessary, well then you might have a problem, and then you might not be able to use this. So I think the convergence of foundation models with in the knowledge space with foundation model in the problem space is actually a very interesting idea that I got sparked with this paper. And I think this is a beautiful example of how these papers they might start somewhere, and they're an interesting sort of path towards a particular problem, and then they open up new doors to all new kinds of approaches. Like in this case, for example, we could have a foundation model for problem solving and then use that as an inference engine on top of a large language model. I think before I end, I just want to mention one more thing, which is something that sort of a thought that got inspired from the book that I'm just reading now, which is Rudolf Diesel's, not biography, but it's a story about Rudolf Diesel, the inventor of the diesel engine. And there's just one passage. I'm going to have a formal review of the book later. But there's one passage in the book which I find very interesting, and that is the question when Diesel meets Thomas Edison. And Diesel is sort of a well-educated engineer with a good theoretical foundation, and Edison is homeschooled and doesn't have a formal education really. So he's the tinkerer, and Diesel is the sort of the theoretician. And I think it just opens up the question that sometimes in AI, in my opinion, comes up all the time, which is the question is, okay, like, is this an empirical science? How much tinkering, how much try and error should we use, and how much theoretical knowledge should we assume before we even start to solve a problem? And I think this tension, it's kind of, whenever something new starts, it comes out of almost serendipity or tinkering, and then people start wrapping their heads around trying to find theoretical problems, etc. So in this case, for example, is there a mathematical way to define what a problem actually is and how to structure a problem, and then assign it to a problem buffer, and also decide and evaluate what is a good solution versus a bad solution? Those are all very interesting questions. I think the eval question, like every other question in AI, also comes up. So to summarize, Buffer of Thought, very inspiring paper, opens up questions in terms of inference and reasoning, opens up the question of a foundation model for problem solving. The same way we have foundation model for knowledge, we could have a foundation model for problem solving, and sort of structure certain types of problems into a problem buffer, and then attach those. Whenever we have a new task, we connect the knowledge base, so a foundation model, with the problem buffer, and then tackle solutions that way. And if we can't find an appropriate problem template in the problem buffer, then we can maybe structure a new problem and add it. So we can also have the buffer, sort of plastically learn, and therefore introduce plasticity into our inference engine. Thank you.